Assalamualaikum. We from Group 7 will present our group project of financial optimization. So these are our group members. First, I will introduce the concept of optimization in finance and how it's applied to portfolio management. Firstly, optimization plays a crucial role in financial decision making. It helps allocate resources efficiently by balancing risk and return, especially when dealing with uncertainty. Historically, Harry Markowitz's modern portfolio theory, developed in the 1950s, revolutionized this approach, and it introduced a mathematical framework that allows investors to create portfolios that maintain an optimal balance between expected return and risk. One of the key techniques in this area is quadratic programming. So this mathematical method helps solve problems where the objective involve square terms, making it perfect for modeling risk. In practical application, quadratic programming uses historical data like past asset returns to identify the best combination of investments. So this approach aims to maximize returns while minimizing risk, and it has become an integral part of many financial tools and software. So our project focused on implementing this model using MATLAB. We formulate and solve portfolio optimization problems with specific constraints, such as budget limits or restrictions on negative investment. So the result demonstrate that quadratic programming provides more efficient, data-driven investment strategies, ultimately improving decision-making and portfolio performance.
Okay, now let me start by explaining the problem we are addressing. One of the most common problems that investors face is how to distribute the capital among several different assets in a way that reduces risk while still achieving a desired level of return. For example, imagine an investor wants to invest in 3 different stocks. Each of these stocks has its own level of expected return and risk. The challenge here is to find the most stable investment proportion for each stock so that overall portfolio risk is as low as possible while still meeting a minimum return such as 11%. At the same time, the investor must fully use the available budget and short selling is not allowed, meaning the investment in any stock cannot be negative. But this problem becomes more complicated when we consider how the stock move together. The portfolio risk doesn't just depend on individual stock, but also how their price move in relation to one another. This is what we call covariance. So, when building a portfolio, investors must take into account both the expected return and how the assets interact with each other. To solve this kind of problem, we can use the Markowitz model introduced in 1952. This model helps investors find the best mix of assets that either minimize risk or maximum return depending on the objective. Since portfolio risk or variance is a quadratic calculation, and constraints like budget and return are linear, this type of problem can be effectively solved using quadratic programming technique.
My name is Nur Azoniza. Next is literature review. First is Markowitz 1952 introduced the idea that investors should assess assets based on their contribution to overall portfolio risk and return, not in isolation. Developed the concept of the efficient frontier where optimal portfolios provide the highest return for a given risk or the lowest risk for a given return. Second is Boyd and Vanderberg 2004 defined convex optimization problem, emphasizing that their structure guarantees global optimality, making them stable and efficient to solve. Highlighted quadratic programming as essential for a portfolio optimization where the objective function is quadratic and constraints are linear. Third is Fabosi et al. 2007 addressed the classical model's sensitivity to estimation errors which can lead to unstable or impractical portfolio. Proposed robust optimization techniques such as worst-case and Bayesian method to improve portfolio stability under uncertainty or poor data conditions. 4 is Zhu 2024 applied quadratic programming to real estate portfolio, showing how incorporating sector-specific risk factor affects portfolio construction. Found that optimization produces more stable and diversified real estate portfolio compared to equal weight strategies. 5. If Kanhu and Minggu 2034 develop a hybrid model combining Markowitz theory and reinforcement learning through a two-stage training process. Use knowledge distillation to teach the reinforcement agent from classical theory, improving learning efficiency and policy robustness. 6 is Boyd et al. 2024 address the classical model's sensitivity to estimation errors, which can lead to unstable or impractical portfolio. Propose robust optimization techniques such as worst-case and Bayesian method to improve portfolio stability under uncertainty or poor data conditions.
In this section, I will explain how we solve the portfolio optimization problem using MATLAB and quadratic programming. The goal is to find the best investment proportions for three stocks, which is stock A, B, and C, so that we minimize risk while achieving at least 11% expected return. To do this, we applied the Markowitz portfolio optimization model. In our model, risk is measured using a covariance matrix, which reflects how the stocks move in relation to one another. The expected returns for the three stocks are 12% for stock A, 10% for stock B, and 15% for stock C. The problem was then solved using MATLAB built-in quadproc function, which is designed to handle quadratic objective with linear constraint. We define the objective functions as minimize 1/2 x transpose qx. This represents the portfolio variance which we want to minimize. For the constraints, first is the expected return must be at least 11% and the total investment must be 100%. And last constraint, we don't allow short selling, so all proportions must be 0 or above.
My name is Nur Wahida Aini binti Ahmad S67425. So this is the result and discussion. Here is the code and the output is optimal investment proportions in stock A 0.4411, stock B 0.3656, stock C 0.1933. Expected portfolio return is 0.1185 and portfolio variance risk is 0.005282. After conducting the Markowitz portfolio optimization process, we obtain the optimal investment allocation that satisfies all the given constraints while minimizing the overall portfolio risk. The main objective was to determine how to distribute capital among three different stocks, such that the portfolio achieves a minimum expected return of 11% is fully invested and this allows short selling. So the optimization takes into account not only the individual risk and expected return of each asset, but also the covariance between the assets, which reflects how their returns move in relation to each other. The results are summarized in the bar chart, which visually illustrates the optimal investment proportions. According to the solution, 44.11% of the total capital should be allocated to stock A, 36.56% to stock B, and 19.33% to stock C. So these proportions are designed to minimize the portfolio variance while still satisfying the return constraints. The higher allocation to stock A suggests that it offers a more favorable balance between return and risk compared to the other asset. Meanwhile, stock B also contributes significantly to the portfolio, potentially offering good diversification benefits. Stock C, despite having the smallest allocation, plays an important role in further reducing overall risk due to its unique correlation with the other assets. In conclusion, this optimized allocation provides a practical and efficient investment decision based on quantitative modeling. It fulfills the investor's objective of achieving a return of at least 11% while keeping risk as low as possible. This result directly addresses the original problem statement and demonstrates how financial models like the Markowitz approach can guide rational investment strategies through mathematical optimization.